Hey fellas, I welcome you to this video and I hope you're all doing fine. So I'm making a series on Heap Memory Manager. So in this series we are going to learn how Heap Memory Manager works and how you can actually make your own from scratch. But the thing is that we are going to learn how these Heap Memory Managers work, particularly for Linux operating system. Okay, so without wasting any time, let's deep dive. Suppose you're having some code, right? And the code is having some lines, right? So this is a program and this is the code, right? Um, and the code is basically it's going to be executed on a processor. Like so, this is a CPU. On this CPU, this code is going to be processed. But thing is that you know we are going to divide the code in some instructions, and each instruction is going to be executed on CPU one by one. But thing is that CPU do not directly fetch the code or instructions. It uses something called main memory. Okay. Well, main memory is like it's like a storage place, which is kind of volatile, uh, and it just stores some data, some instructions mostly, which can be used by the CPU at the time of processing. Okay. So when it is processing, it can actually store all these instructions into it, and this is more or less like a memory only. It can store uh, data or instructions. So what happens is that we store these instructions to the main memory, and then CPU can directly fetch those instructions from the main memory because first of all it's fast, right? uh, we cannot do it from hard drive, hard disks, because they are slow. Okay. And yeah, so that's actually one of the main reasons why we use main memory. And by now I am guessing you might have understood that main memory here can be your RAM. So we basically use DRAMs, then we also use SRAMs, but these SRAMs are basically uh, used in L1 or L2 cache, right? But we are not going to go into the depth of that, right? We are going to stick to the DRAM. Okay, that's cool. Let's erase it. Let's erase that too. Okay. Now imagine that. Okay, suppose that this code, this whole program, it's some application, and the name of the application is my app, any name. And now when this application is running on a CPU, it has formed some processes like P1, P2, and so on, maybe up to Pn. Well, the thing is that we do not really need Pn, it just we need some processes to show. It can be any arbitrary number of processes, okay? And let's say that the process P1, it asks for the allocation, it asks for the allocation of memory, let's say that, for example, you may understand that int array of 10, right? So if this is the process, then it's actually asking for 10 times the size of int memory in RAM. Okay, and similarly, it can happen that P2 process, it may ask for deallocation of a memory. Okay, so let's say that in P1 we allocated some memory, and in P2 we are deallocating that particular memory again, right? So, uh, for example, here we allocated array of 10, and then we deallocated the allocate that array itself. Okay, right? So, well, I don't think that it's kind of difficult, and we have been using it for all the time, since we are coding. So what we can do is, um, we can say that, okay, well, P1 asks for the allocation of a memory, then P1 can directly ask the main memory, hey dude, can you allocate some memory for me? Well, okay. And similarly, P2 can ask uh, to main memory, hey dude, can you deallocate the memory that you allocated earlier? Well, thing is that any process or any software cannot directly communicate with physical devices. Well, this is a main memory is a physical device. It's a physical memory, right? It's a physical memory. And processes, they are software based. Now, thing is that any software cannot directly communicate with a physical device, a physical memory. And so for that, we have actually made something called kernel. Uh, I'm really sorry for that. The spelling is wrong. Uh, yeah, so we can write here kernel. Okay, so kernel. Okay, let's understand a little bit about kernel. Kernel is basically like it bridges software to hardware. Okay, so now what will happen is that these uh, these processes, they will first of all reach out to kernel. Okay, and they will say, and P1 will say, hey dude, can you allocate some memory for me of some size, this much size 1, right? Anything. Kernel will say, okay, yeah, of course I can do it. Let me give some time, and it will then go to the main memory, and we can actually show the main memory in this way. Okay, it will say, okay, well, it seems like there is some space. Cool, I can allocate it. And what it does was, well, it will allocate this size 1 amount of memory in the DRAM here.